Hello everybody, this lesson is from Unit 1, Lesson 4 on functions, and just a quick go over some vocabulary. From the previous lesson, a relation is just a set of ordered pairs comparing x and y coordinates, and for those x and y coordinates we learned that a domain is the x coordinate or the input values, and a range are included with the y coordinates or output values. What's different about a function is it's still like a relation, but it has specific rules. The specific rule for a function that makes it a function is that it assigns exactly one domain value, so exactly one x value, with exactly one range value. So this means that for any x value in your relation or in your function, it has to match up with only one y value. So we'll look at some examples of what functions look like. In this first example, we have a listing of ordered pairs. And if I look at all of my domain values, all of my x values, I have a 1, a 5, and a 7. They're all different, and they're each matched up with only one range value. So this one is a function. Each x is matched with exactly one y value. Looking at example number 2 as a table, I'm looking at all of my different x values. I have a -3, a 2, a 6, and a 9. Even though they're all matched up with a 4, each x value is different, so that's okay. So -3, if you put in -3 into your function, you get out a +4. So the y's, again, are your range values. The x's is the domain. So the domain has to match with 1. So 2 matches with 4, 6 matches with 4, and 9 matches with 4. Because all of these x values are different, it is okay that the range values are the same. Okay, so the x values just have to be different, and they have to match up with only one range value. If, for example, in my table, if I extended this down, and I had -3 again, but instead I had 0, this would be where it would no longer be a function, because at one point I put in -3 and got out 4, and then you try it again, put in -3 and I got out 0. This would be a case where it's not a function. Okay, so you have to put in the same x value, and you should get the same y value every time you put that value in. Another example with an arrow diagram, notice that each x value points to only one y value. A case where this would not be a function would be if, for example, this 4 also pointed to 0. So this would basically be saying that they put in 4 one time and got out 1. They put in 4 again and got out 0. This would cause it to be not a function. But as long as each value, each x value, is matched up with only one range value, then it is a function. So this one is a function. And the last type of function that display that you'll see, you can look at a coordinate grid. Each of these points represents an x and a y value. Okay, so the easiest way to determine if this is a function is looking to see if there's multiple dots on the same line for the x's. So the x coordinate of this point is -3. There's no other points on that line. The x coordinate of this one is -2. There's no other options for -2. The x coordinate of this one is 0. X coordinate of this one is 1. X coordinate is 3, and on this one is x coordinate is 4. So you're looking at the x coordinates and making sure they're matched up with only one y coordinate. And with a coordinate grid like this, the easiest way to determine if it is a function or not is if it passes what's called a vertical line test. So if I were to draw a vertical line and drag it across this graph, I should only hit one point at any given time. So right here, I hit one point. There's only one point on that line. Here's another one. Only one point on that line. 1 point, 1 point, 1 point, and 1 point. So it passes the vertical line test because there's only 1 point on a vertical line at any given time. If I had another point drawn on, let's say I had a point here. If I were to take my vertical line, it would no longer pass the vertical line test because now there's 2 points on it. There's this point and this point. So in order to pass a vertical line test, you can only have 1 point on the graph or on that line at any given time. So to make it a function, that point wouldn't be able to be there. So just some examples to help determine if something is a function. If you're given a table, you want to look at the x values. Look to see that they're all different. Okay, so we have a -6, -4, 0, 2, and 4. These are all different and they're all matched up with only one y value. Again, these two can be the same because the x value is different. That's okay. But each x value is only matched with 1. So this one is a function because each x value is only matched with one y value. So none of the x's repeated, which would show you that they match with two different values. Here's another example, but with a graph. Since it's a graph, we can use our vertical line test. So I'm going to draw a vertical line, and I'm going to drag it across. So, oops. So if we're looking at this, we want to make sure that this line, this is our graph here that we're comparing. Each point on here represents a coordinate. So this line should not intersect it more than once. So if we look at it right here, maybe it's at one spot, but as we get over here, for example, it's intersecting this graph there and there. So since it's crossing at 2 points, this one is not a function because it failed the vertical line test. There was 2 points at one time on this vertical line. One more example showing ordered pairs. Again, first look at your x values. So I have a -2, 4, 3, 6, and 4. I see two x value or an x value that repeats. One time they put in 4 and they got out 5. Another time they put in 4 and they got out -4. So this is showing the same x value, but they got out a different y value each time they put in that value, that number 4. So this one is not a function because 4 can only be matched with one y value. And then also in this lesson, you'll be asked to evaluate functions from graphs and from tables. And so they'll say evaluate the function for a given point. So in this function, this line is our function. And they want you to identify it when, or what the value is for y when x equals 5. So you'll find 5 for your x coordinate and see where it's crossing on your graph, because this is our function. So when x is 5, so right here, our x was 5, so then the y is the y coordinate. The y coordinate is 4. So when x is 5, y equals 4. So you're looking for the point on the graph where that coordinate is to figure out what the y value is. Same idea with a table. If this represents our function, we want to figure out when x equals -1, what is y? So looking at our table, here's where x is -1, the y is -2. So we would say that y is -2. And one helpful hint to help you with thinking about functions, if you think of functions as a machine, you're putting values in. So think of like a vending machine. You're putting something in, applying some process, and getting something out. So the thing you put into your vending machine is your domain, your x value. The process is like the equation that you do, or like if you think of vending machine, the number series that you type in. And then the output, the thing you get out, your y value, it would be like the candy or the chips. So think of it as a vending machine. Inputs, what you put in, are your y values. The function itself is the process that you do to get the item. and then the output is the thing that comes out of the machine, so the y value.